So today we're going over 1.5 notes for geometry. We're going to talk about angle relationships. Our objective is to classify angles and calculate angle measures. So we're going to start by talking about the definition of adjacent angles. So adjacent angles are two angles that lie in the same plane and have a common vertex and a common side but no common interior points. So let's break down the definition a little bit. We need to look for three different things. We need to check to see if the angles have a common vertex. We need to check to see if they have a common side, and we need to check if there are no common interior points. Okay, if all of these things are true, then we have adjacent angles. Okay, well let's look at, I erased it. Let's look at angle 1 and angle 2 in this example. Okay, well angle 1 is, let's see, what's angle 1? Angle 1 is this right here. It's that orange angle that I highlighted, and angle 2 is this pink one. Okay, those are the two different angles, angle 1 and angle 2. So now let's look at their vertex. So what's the vertex of angle 1? Well, the vertex of angle 1 is this point right here. Okay, now what's the vertex of angle 2? The vertex of angle 2 is actually that same point. So they have a common vertex. So I can put a check mark. Okay, well that's true. Now let's check to see if they have a common side. Okay, well let's look at that middle side, right? This middle side right here is both orange and pink because it's a part of both angle 1 and angle 2. So that is also true. The two angles have a common side. Okay, now let's look to see if there are no common interior points. Okay, interior points is talking about the inside of the two angles. So let's look at the inside. So the interior of angle 1 is actually all of this, everything that I highlighted. Anything that's on the inside of angle 1. And the interior of angle 2, same thing, is everything on the inside of angle 2. So if I have a point P, any point, right? It can be anywhere inside of angle 1. If it's inside angle 1, it's not going to be inside angle 2 because angle 1 and angle 2 are two different angles. Okay, they don't share any points. So this last part, no common interior points, that is also true. Because all of these things are true, I can say that angle 1 and angle 2 are adjacent angles. Okay, cool. And if you just think about adjacent, well, what does adjacent mean? Adjacent means next to. So that's just a little tip to help you remember. Adjacent means that they're right next to. So angle 1 is right next to angle 2. Okay. Now let's look at this blue example over here. So for the blue one, we're looking at angle 3 and angle ABC. So I'm going to highlight again. Angle 3 is this one, right? That's angle 3. And angle ABC is this pink one, ABC. Okay, so let's start by checking to see if the angles have a common vertex. Well, what's the vertex of angle 3? The vertex of angle 3 is just point B. Okay, now what's the vertex of angle ABC? Same thing. It's point B. So they do share a vertex. They have a common vertex. Okay. Now let's check to see if they have a common side. If both angles have a common side. Well, let's look at this angle, this side right here, side BC. Notice how it's orange and pink because they both of the angles share it. Okay, so that's true. They have a common side. Lastly, we need to check to see if there are no common interior points. So we're talking about interior again. We're talking about the inside of the angles. The interior of angle 3 is this, and the interior of angle ABC is all of this. Notice how it overlaps, right? Angle 3 is pretty much inside of angle ABC. So if I have a point, let's say right here, point P again, point P is inside of angle 3, but it is also in angle ABC. So they have a common interior points, but we didn't want that. We were looking for no common interior points. So this is actually not true about both of these two angles. So since that last part isn't true, then these two angles are not adjacent. So angle 3 and angle ABC are not adjacent angles. Okay, and remember, let's think back to what adjacent means. Adjacent means next to. These two angles are not next to each other because one of them is inside of the other. Okay, so think of what adjacent means. Now let's go over linear pair. Linear pair, the definition is a pair of adjacent angles with non-common sides that are opposite rays. And let's look at this green example first. We're looking at angle 1 and angle 2. And I'm going to highlight again so I can think of angle 1 is this one. That's angle 1. And angle 2 is this one over here. So by definition, these two angles need to be adjacent angles, and they are. They're adjacent. They're right next to each other. They're two different angles that are next to each other. So I have angle 1 and angle 2. They're adjacent. Okay, cool. With non-common sides that are opposite rays. Non-common sides that are opposite rays. So I need to look at the non-common sides. Okay, well, they share this middle side right here because it's both orange and pink. So I need to look at the non-common sides. So if they share that side, the non-common sides are these two sides, right? And I needed to check to see if they are opposite rays. Well, they actually are opposite rays because it's a straight line with a point in the middle that starts two different rays. Okay, so then angle 1 and angle 2 form, let me erase that. Angle 1 and angle 2 form a linear pair. And you can also think of the word linear, right? Linear, think of line. So if two angles, you're looking for two angles that make a line. Two angles that make a line, okay? Right, so angle 1 and angle 2, if you combine them, they form this straight line. So that's what we're looking for, okay? Now let's look at the example over here in the blue. Okay, well, let's look at, we have two different angles, right? We have angle ADB, so ADB, and then we have angle ADC, so angle ADC. So remember, these two angles are adjacent, right? Linear pair is a pair of adjacent angles. They're adjacent because they're next to each other and they're two different angles, okay? So now we're looking to see if they have non-common sides that are opposite rays. So ADB and ADC share AD, right? That's the common side. So we need to look at the non-common side. The non-common sides are, erase that. The non-common sides are BD and DC, right? So we need to check to see if they are opposite rays. They actually aren't opposite rays because they don't form a straight line. If these two rays would have formed one straight line, so like this one over here, see how it's straight, then these two rays would have been opposite rays, but it does not form a straight line. So because it doesn't form a straight line, I have to say that ABD and ADC do not form a linear pair. Okay, and remember, let's think about if the two angles make a line. So do these two angles form a straight line at the bottom? No, they don't. This one over here did. I can draw a straight line, but these two angles, you see, it's not straight. Like this is one side and then this is another side. They don't form a straight line. Okay, so they're not a linear pair. Whoops, what's going on? Okay. Now let's talk about vertical angles. So vertical angles are two non-adjacent angles formed by two intersecting lines. And then we can say that vertical angles are congruent. Okay, so we have two lines here that are intersecting, right? These two lines intersect. So we're looking for non-adjacent angles. Remember, adjacent, if we just think about adjacent, what adjacent means, that means next to each other. So adjacent angles would be like 1 and 4. They're right next to each other, or 1 and 2. They're right next to each other and they share this side, right? So non-adjacent sides would be like 1 and 3. So we can say that angle 1, sorry, it's all weird, angle 1 and angle 3, that looks bad. Angle 1 and angle 3 are vertical angles. Okay? They're not adjacent to each other. We can also think of angle 2 and angle 4. Those are also vertical angles because they are not adjacent to each other. Adjacent, remember, means like they're like right next to each other. You can also think of vertical angles as just like being angles that are across from each other. Because remember, adjacent was like next to. Let me show you. So adjacent is like these two are right next to each other, but vertical means across, so that you have to cross to the other side, to the other angle, okay? But yeah, just remember that vertical angles are angles that are not adjacent to each other. Great. Okay, let's move on. Now we're working with complementary angles. So complementary angles are two angles with measures that have a sum of 90 degrees. So sum of 90 degrees, that means that the two angles added together equals 90 degrees, okay? Let's look at this first example over here on the left. If we notice that there's this square on the inside of the angle, that means that there is a right angle, right? So that means that that's a right angle. Well, what's a right angle? A right angle is equal to 90 degrees. Okay, so if I tell you that both of these, if I tell you that this whole angle right here is 90 degrees, that means the two angles that make up the big angle added together equals 90 degrees. Okay, so this little symbol right here means that it's not 90 degrees, so I know that angle 1, what is up with my pen, and angle 2 are complementary angles. Or I can say that angle 1 plus angle 2 is equal to 90. That's what complementary means, right? 90 degrees. But they add up to 90 degrees. Now let's look at this other example over here. Okay, well, I have angle A. Angle A is 65 degrees. Angle B is 25 degrees. Remember, complementary means that the two angles, the sum of the two angles is 90. So I have to add them to see if they're 90. Well, if I have 65 and I have 25, so I add those two numbers together, right, I get 90. So these two angles added up together equal 90. So then that's true. So they are complementary angles. I can say angle A and angle, and angle B are complementary angles. Okay? Complementary just means 90 degrees. They add up, two angles add up to equal 90 degrees. Okay? If we're talking about supplementary angles, so complementary and supplementary angles are two angles with measures that have a sum of 180 degrees. So you have two angles that add up to equal 180 degrees. If I look at this example on the left, so I have angle 3 and angle 4. So remember, if we have a straight line, a line always equals to 180 degrees. This line is straight, and this line is made up of angle 3 and angle 4. So because the line is straight, the line has a sum of 180 degrees. So that means angle 3 and angle 4 are supplementary angles. Supplementary angles. Okay, the two angles add up together equal 180 degrees. So I can say angle 3 plus angle 4 is equal to 180 degrees. And I don't know what angle 3 is. Like, I don't know how many degrees it is, and I don't know how many degrees angle 4 is, but I know together they add up to equal to 180 degrees because, again, we have a straight line right here. This straight line is 180 degrees. A straight line is always 180 degrees. Okay. Now over here I have angle P and angle Q. Angle Q is 60 degrees and angle P is 120 degrees. So if I add those two numbers, so I have 120 plus 60, that's 180. So these two angles add up together equal 180. So I can say angle P and angle Q are supplementary angles. Okay, they add up to equal 180 degrees. Okay, and just a little note here at the bottom, I put that the angles in a linear pair are supplementary, right? So if we go back up to linear pair, remember how I said linear pairs, like this example right here, form a line. A line is always 180 degrees. So if you have two angles that are linear pairs, they are also supplementary because they add up to 180 degrees because they form a line. Okay. Now let's talk about perpendicular. So lines, segments, or rays that form right angles are perpendicular. And then we have some properties over here on the right. So perpendicular lines intersect to form four right angles. Perpendicular lines intersect to form congruent adjacent angles. Segments and rays can be perpendicular to lines or other line segments and rays, and the right angle symbol in the figure indicates that the lines are perpendicular. So if two lines cross, right, if two lines cross and they form four right angles, remember that little square inside the angle means that it's 90 degrees. So if I have four of those, and we technically do have four, because if this one is 90 degrees, vertical angles are congruent, so this one is also 90 degrees. And remember, this is a straight line. A straight line is 180 degrees, so if this is 90, this is also 90. And if this is 90, this is also 90. So right here, we have four right angles. So that means these two lines, AD, so we have line AD is perpendicular to line, oh, I was right, to line BC. Sorry, yeah. So because we have four right angles, line AD is perpendicular to line BC. And remember, this can be any lines that are perpendicular. You can have lines, you can have segments, or you can have rays that are perpendicular, as long as they form right angles. We just have to have four right angles. So remember, okay, and if we look over here, so perpendicular lines intersect to form congruent adjacent angles. So if we think of this angle right here and this angle right here, they are congruent and they are also adjacent. And the symbol for perpendicular is this line, the one that I wrote. So it's like this upside down T. That means perpendicular. Okay, so we read this as line AD is perpendicular to line BC because it creates four right angles. Okay, Now let's go over some examples. So here it says, find the measure of two supplementary angles if the difference in the measure of the two angles is 18. Okay, so it's a word problem, but we can do this. We just gotta look at the different parts. So find the measure of supplementary angles. Okay, so they tell us right off the bat that we have supplementary angles. Okay, so I'm going to highlight that we have two supplementary angles. Well, what does supplementary mean again? Supplementary means that the angles added together equal 180 degrees. That's what supplementary means. Okay, if we look back, supplementary means that the two angles added together form 180 degrees. Okay, so that means angle A. So we have angle A and angle B in this picture. That means that angle A plus angle B is equal to 180 degrees. Okay, well, what else do we know? We also know that it says find the measure of two supplementary angles if the difference in the measures of the angles is 18. So the difference in the measures of the two angles is 18. So remember, difference means subtraction. So that means if I take angle A and I subtract angle B, that will give me 18. Okay? I take the two angles and I find the difference, I subtract them, I should get 18. Okay, so I'm working with a few different things here. What else do I know? Well, if I look at the picture, I know that angle A is actually equal to x degrees. Like, that's how they label it, right? Angle A is equal to x degrees. So I can actually take, since angle A is equal to x, I can take these two equations that I wrote and I can substitute in x for angle A. So I can have, if I rewrite this one, right, I can have x plus angle B is equal to 180 degrees. And if I rewrite this one, I can say x minus angle B is equal to 18. Okay, well, I know what angle A is, so let's try to rewrite one of these equations so that I have angle B by itself. So let's try to do it with this top one. Okay, so I want to get angle B by itself. I want to find out what angle B is. So I can just subtract, let me use a different color. I can subtract x on both sides to get angle B on its own, right? Because I have x minus x, that'll go away. So I just have angle B is equal to 180 minus x. Okay, so now I know what angle B is equal to. Right? I don't know the exact value for angle B, but I have something that I can rewrite angle B for. Okay, so now since I have this for angle B, I can take that and substitute, or actually not that, sorry. Since I have angle B is equal to 180 minus x, I can take that and I can substitute it into this second equation. So I can rewrite it as x minus angle B, which is 180 minus x, all of that should equal to 18. Okay? Now we're just pretty much solving for x. Okay, and that's what I'm trying to find, right? I'm trying to find the measure of two supplementary angles. One of the angles is angle A, which is x. I'm trying to find x. Okay, so I'm going to start by distributing this negative. I have this minus. I'm going to distribute that into the parentheses because it's technically a negative 1. So I'm distribute that into the parentheses. So I have x, and I have negative 1 times 180. So that's a negative 180. And then I have negative 1 times negative x. So a negative times a negative, that's just a positive. So I have positive x is equal to 18. Okay, now I need to combine like terms, right? I have these two x's right here. I can combine them. What's x plus x? X plus x is 2x. And I still have that minus 180. And it's still equal to 118. Okay, I'm still trying to solve for x. I'm going to add 180 on both sides. Add 180. I'm just going to rewrite this over here. So I have 2x on the left is equal to 18 plus 180. That's 198. I'm still trying to solve for x. My last step is to divide both sides by 2. So I'm left with x is equal to 99. Okay. So if x is equal, so I can, this x is equal to 99. Remember, these two angles are supplementary, meaning that, one plus the other is equal to 180. So if I have a is equal to 99, I can just substitute it into one of these equations. So, or I can just subtract 99 from 180, because both of these two angles are supplementary. They add up to 180. So if I take 180 minus 99, that'll give me the angle measure of angle B. So this is actually 81. And that's the measure of angle B. So angle B is 81. Okay, so angle A is 99 and angle B is 81. Okay, but always write down what you know given the information that they gave you. Number 3, find the measure of two complementary measures if the measure of the larger angle is 12 more than twice the measure of the smaller angle. Holy goodness, I don't know. So I like to draw pictures, right? So it says that we have find the measure of two complementary measures. What does complementary mean? Complementary means 90 degrees. Oh, let me use a different color because I just used red. Complementary means 90, supplementary means 80. So I know I have a 90-degree angle, right? If this is my 90-degree angle, and this 90-degree angle is two different angles, so two different angles added up create this 90-degree angle. And it tells me one of them, so two complementary measures, if the measure of the larger angle, so I can think of this angle right here as the larger one, and this one as a smaller one. It says the larger one is 12 more than twice the measure of the smaller one. So let's call this angle 1, and let's call this one angle 2. Angle 1 is the larger one, and it is 12 more than twice the measure of the smaller one. So 12 more means plus 12, twice the measure of the smaller one. So 2 times angle 2. Let me rewrite this. So 12 more means plus 12. 12 more than twice the measure of the smaller angle. So twice times 2 the measure of the smaller angle, which is angle 2. Okay, so I can rewrite this over here. So the measure of angle 1 is equal to 2 times the measure of angle 2 plus 12, and then I don't know what the measure of angle 2 is. That's just angle 2. Okay? What else do I know? Well, okay, these two angles are complementary, right? Remember, complementary means if you add them together, they add up to 90. So let me erase that. And I can just say that the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. Okay? What I can do from here, since I have measure of angle 1 over here, and I also have I have measure of angle 1 is equal to 2 times the measure of angle 2 plus 12. So I can, since I know that this whole thing over here, it's the same thing over here what we did. Since I have this whole thing is equal to the measure of angle 1, I could just substitute that in to this left side. Okay, so I can do 2 in parentheses the measure of angle 2 plus, erase that, plus 12 is equal, oh sorry, no, not equal to, plus the measure of angle 2 is equal to 90. So all I did was I took the measure of angle 1, I took whatever that it was equal to, and I plugged it into that second equation. Okay. Now I'm going to just solve for the measure of angle 2. Just think about that as x. The measure of angle 2 is just x. I'm just solving for x. So 2 times the measure of angle 2, that's just 2, the measure of angle 2, plus 12, plus the measure of angle 2 is equal to 90. I'm going to combine like terms, where I have 2, the measure of angle 2, and 1, the measure of angle 2. If I can combine them, I can do 3, the measure of angle 2, plus 12 is equal to 90. I'm just solving for the measure of angle 2. That's what I'm trying to find. Okay, I'm going to write this up here. So then I have 3, the measure of angle 2 plus 12 is equal to 90. I'm going to subtract 12 on both sides. So then I have 3, the measure of angle 2 is equal to, what's 90 minus 12? 90 minus 12 is 78. I want to get this measure angle 2 by itself. I'm going to divide by 3 on both sides. So that means the measure of angle 2 is equal to 26. Okay, remember I have angle 1 and I have angle 2. So angle 2 is equal to 26. And remember, the two angles added together, angle 1 plus angle 2 is equal to 90. So if I know that one of them is 26, all I have to do is do 90 minus 26 to get the other one. So 90 minus 26, that's 64. So that means the measure of angle 1 is equal to 64 degrees. Okay, well, that's my answer there. Okay, now let's go over an example with perpendicular lines. Oh, and I'm actually missing a lot of words here. Okay. Well, it's supposed to say, I don't know what happened there. It's supposed to say find x and y so that line PR and SQ are perpendicular if line PR is perpendicular to SR, then the measure of angle STR is equal to 90, and the measure of angle PTQ is equal to 90. Okay, so we're trying to find x and y so that line PR, so line PR, this, let me highlight that, line PR is this one, so that this line and line SQ, so that these two lines are perpendicular. Okay, remember, so let's assume that they are perpendicular, and let's work that way. Okay, so if we assume that these two lines are perpendicular, then remember, when two lines are perpendicular, they create 4 90-degree angles. So there's a right angle right here, a right angle here, a right angle here, and a right angle here. Okay, we have 4 different right angles. We're trying to solve for x and y. Okay, well, let's start with y. I know that this, okay, let me erase what I highlighted. Let's look over here. So I know that this angle right here, angle PT, is that T? Yeah, angle PTQ is equal to 90 degrees, right? Because if these two lines are perpendicular, then PTQ is 90 degrees. I also know that PTQ is equal to 4y minus 2. So let me write that down. So I know that, let me use a different color. Just a lot of blue. Let's use orange. Okay, so I know that angle PTQ is equal to 90 degrees. I also know that PTQ is equal to 4y minus 2. If I want to solve for y, I just set these two equal to each other. They both equal to PTQ, so I can just set them equal to each other. So I can do 90 is equal to 4y minus 2. I'm trying to find x and y. Okay, so I'm going to find x and y. I want to get y by itself. I'm going to add 2 to both sides. Give me 92 is equal to 4y. I'm going to divide by 4 on both sides. So that'll give me y is equal to 23. Okay, so if the lines are perpendicular, then y will equal 23. So if y is equal to 23, that means that the two lines are perpendicular to each other. Okay, so we have to assume that they are perpendicular to find x and y. Now let's find x. Okay, so let's focus on over here because this is where we have x, right? If we look at angle STR, STR is where we see a bunch of x's, so let's look right there. Okay, well, STR is a combination of two angles, right? It's a combination of STW and WTR. So those two angles added together create STR. So if I want to write that in words, I can say S angle STW plus, right, STW plus angle WTR make up angle STR. Okay, and remember STR, angle STR is equal to 90 degrees if the lines are perpendicular. Okay, what else do I know? I know that STW, so this angle right here, STW is 2x. They gave me that. They told me STW is 2x. And they also tell me that WTR is 5x plus 6. So I can just write that here. 5x plus 6. And then, well, what's STR? STR is 90 degrees. I'm just substituting in everything that they gave me. Okay? So I should actually write this down here. So I have 2x plus 5x plus 6. All of that is equal to 90 degrees. Right? Because I have this 2x, I have this 5x plus 6, and the whole angle equals 90 degrees. Okay, now I'm just solving for x. That's what I'm trying to find. I'm trying to find x and y. So I can just drop the parentheses. I have 5x plus, or 2x plus 5x plus 6 is equal to 90. I want to get x by itself, so I need to combine like terms first. 2x plus 5x, that's 7x. So I have that plus 6 is equal to 90. I want to get x by itself, right? So I subtract 6 on both sides. I'm left with 7x on the left side, and then I have 90 minus 6. 90 minus 6 is just 84. I want to get x, so I divide both sides by 7. So I get x is equal to 12. Okay? Cool. Let's move on. Next one, number 5. I don't know what happened. All the numbers just went away, and I didn't even realize. Okay, so it should say, suppose the measure of angle D is equal to 3x minus 12. And then just say find x so that angle D is a right angle. Okay, so remember, let me erase that. So that angle D is a right angle. Okay, so they tell us the measure of angle D is equal to 3x minus 12, and they also say that angle D is a right angle. So I know that the measure of angle D is equal to what if it's a right angle? If it's a right angle, remember right angle means 90 degrees. So I can say the measure of angle D is 90 degrees. Both of these things are equal to the measure of angle D, so I can just substitute it in or set them equal to each other. So I can do 90 is equal to 3x minus 12. I'm taking this value and I know that it's equal to the measure of angle D, so I'm plugging it into this equation over here. That's all I'm doing. Okay, I'm setting them equal to each other. And I'm just trying to find x. So to find x, I want to add 12 on both sides. If I add 12, that's 102. Over here on the left, I still have that 3x. I want to get x by itself. I divide by 3 on both sides. So then I get 34 is equal to x. And that's it. Okay, remember 90 degrees, a right angle is 90 degrees. And I just substituted 90 in for the measure of angle D. Okay, almost done. It says determine whether each statement can be assumed from the figure, and it wants us to explain. And I erased it again. Okay, so we want to check to see if, let me use a different color. Let's see. Let's use blue. Okay, so I need to check to see if angle D, B, C, and angle A, B, G. A, B, G are complementary. It's kind of close together. A, B, G are complementary. Okay, well, first of all, let's think about this. What does complementary mean? Complementary means 90 degrees, okay? So we're checking to see if angle DBC and angle ABG are 90 degrees. So I'm going to highlight those. So let's see, where is it? DBC and ABG. So are these two angles complementary? Do they add up to 90 degrees? So both of these angles added up together should equal 90 degrees. Is that true? Do I know that from the picture? Okay, well, what do I know? I noticed that both of these angles have this little line, kind of this like curved line in them where the angle is. That just means that they are congruent. So I know that angle, sorry, I keep writing the wrong thing. So angle DBG is congruent to angle ABG. Okay, so I know that they're congruent. That's cool. But are they 90 together? So if they're congruent, that means that this one has to be 45 and this one has to be 45, right? Because 45 plus 45 is equal to 90. Well, I don't know that. I don't know that. Just based off of the picture, if I'm looking at the picture, I don't know that that's true. So I can't say that. I can't say that they're complementary. So no, because we don't know the angle measures of angle DBC and angle ABG. Okay. The next one, use a different color, is supposed to say, I don't know what happened, supposed to say angle ABD and angle CBD are a linear pair. So we're trying to see if this is true. Is it true that both of the angles are a linear pair? Do they form a linear pair? I'm going to highlight again. So AB and ABD and CBD, these two lines. Remember, linear, when we think of linear, think of line. So do these two angles added together form a line? Okay, well, yes, right? If I see this orange angle ABD is this big angle right here, and then we have the smaller angle CBD, these two lines together create this big line, create that line, create this line right here. Okay, so it's because they create that line, I can say that they form a linear pair. So, yes. And if I want to use like the definition of linear pair, you know, I can say that yes, because angle B, or I mean not angle, ray BA and ray BC are opposite rays. This is just based off of the definition of linear pair. Are opposite rays, and angle ABD and angle CBD are adjacent angles. Okay, now we erase this. You can use a different color, you can use pink. So now we're looking to see if line BF is perpendicular to line BG. Okay, well let's highlight them. So I have line BF, and then use green, and line BG. So are these two lines perpendicular? Let's go back to the definition of perpendicular. Where's perpendicular? Perpendicular, so it says line segments or rays that form 90-degree angles are perpendicular. So we have line segments or rays that form a 90-degree angle, then they're perpendicular. Okay, well if I look at BG and BF, what's on the inside of that angle? Notice that there's this little triangle. That triangle means that it's a right angle. So if it's a right angle, it's 90 degrees, that means that the two rays are perpendicular. Okay, so yes, because line BF and BG form a right angle. Okay, so since there's that right angle, that means the two lines are perpendicular. Okay, the next one, trying to see if angle ABF and angle FBC are supplementary. So what does supplementary mean again? I don't know. What do you think? Go look at your notes. Supplementary means that they add up, two angles add up to 180 degrees. Remember, complementary is 90 degrees, supplementary is 180, okay? Look back at your notes, look at the very top to see, okay? So let's look at the angles, let's highlight. So we have ABF, and then we have different color. We have FBC. Okay, well notice that these two angles make up a line, right? Makes up this big line ABC. Those two angles added together create this line. Well, a line is always 180 degrees. So yes, these two angles are supplementary because they make up this line, and the line is 180 degrees. So I can say yes, because the two angles form a line. Whoops. Sometimes this pen just has a mind of its own. Form a line and a line equals 180 degrees. Okay, different color, orange. Now we're checking to see if angle ABG and angle GBD are adjacent angles. So are they adjacent? Remember, adjacent means right next to. The formal definition is to make sure that they have a common side, a common vertex, and no common interior angles. So let's highlight them. We have ABG. ABG is this one, ABG. And GBD. GBD. Okay, well, are they next to each other? Right, adjacent means next to each other. Okay, well, yeah, they're next to each other. Now let's look at the formal definition. Do they have a common side? Yes, they have a common side. They have GB. Okay, do they have a common vertex? Yes, they have a common vertex. A common vertex is point B for both of the angles. And lastly, are there no common interior points? These are two different angles. It's not like the example where there was one inside of the other. So that means that they each have their own interior points. So there are no common interior points. So yes. Yes, the angles are adjacent. And I can say common vertex is B. Common vertex is B. The common side is, oh, it's a ray, is ray BG. And there are no, my bad. There are no common interior points. Okay, perfect. Great job, guys. I will see you soon in class.